All right, here's part 2 of section 10.4. We had 2 inscribed angles before. Now we're going to do another inscribed angle, but watch what we're going to do with this. Let's draw a line. What I'm going to do is I'm going to draw a diameter. It doesn't have to be exactly, straight across horizontally. I could go like this if I wanted to. It doesn't make any difference. So just to be a little bit different, we'll take it at a little bit of an angle. All right. So here's a diameter. What I'm going to do, I'm going to come up here somewhere. Actually, it could be anywhere. And I want to draw an inscribed angle so that it cuts off the diameter. All right. So actually, let's go to this. What I'm going to do, it could be anywhere. It doesn't have to be right here. I'm just picking any random spot. Okay, there's nothing special about the place I'm picking right here. I'll just say right here. Now watch this. If I come down to here and I make another all the way to this endpoint right here, what did I just do? I just made a what kind of an angle? Well, we don't know that yet, but we do know that you go from a point on the circle. Kelsey, you watching? Okay, are you busy drawing little pictures and stuff? Why don't we take notes on geometry instead of doing that? Okay. So watch, if we started right here, we go here and we go here, what did we just do? We drew a what? No, the red. Say it, Isaiah. Inscribed angle. Okay, this is an inscribed angle. Would you agree? Because the vertex of that angle is right on the circle. But it's not just any inscribed angle. I just didn't take it anywhere. Look where I ended up. I cut off this whole big arc right here. What's this big arc right here? It's a semicircle, which is how many degrees? 180 degrees. So it cuts off 180 degrees. What did we just learn about an inscribed angle? What does it do? It's what of the arc? Half of the arc. That's right. So look at this angle right here. This angle is half of the arc that it cuts off. You see that? So it cut off this arc right here, which is 180 degrees. So this angle has to be half of 180 degrees, which is 90 degrees. So that would be 90 degrees right there. Do you see it? It doesn't matter where I am. I could do it. Let's just do a little variation of this. Let's just pull this and just go to another spot. I don't know, right there. Is that a nice spot? And let's pull this right there. All right, there we go again. But look at this. It's still an inscribed angle, and it still cuts off 180 degrees. So this angle still must be what? 90 degrees. Do you see it? So it doesn't matter where on the circle. If it's cutting off a semicircle, that angle has to be 90 degrees. And we'll just show you several different variations of this. Okay, right there. That's still 90 degrees, isn't it? Why? Because it cuts off a semicircle. Semicircle is 180 degrees. So this is going to be half of 180 degrees. So we can confidently say that that right there is going to be a right angle. Make sense? All right. So that's not too hard. Any questions on that one? On why it is or anything like that? All right. Let's pause that and resume. Okay, now we have another circle. And we have a diameter drawn like we had before. All right, and here's, kind of looks like what I did before. I guess I could have just kept that same circle, but that's okay. And this is an inscribed angle, isn't it? So we know that what we just learned a second ago, what's this going to be right here? 90 degrees. Okay, so we know we have a right angle. Now, if you look, I'm taking this right from the example in the book. It's on page 712. All right, so we're going to call this angle F. This is G, H, and I think this is J. Yeah. And this angle is 4x plus 2, this one right here. And this angle down here is 9x minus 3. All right. And it actually asks, you'd think they would just ask for x, but they actually ask you to solve for angle F. All right, now take a look. By knowing that this is a right angle, it's an inscribed circle, but what does it cut off? It intercepts a semicircle. Do you see it? So that's 180, it's half of it. So you have to know this. They don't put the little right angle there. You have to know that that's a right angle because it's cutting off a semicircle. If it cuts off a semicircle and it's an inscribed angle, it has to be 90 degrees. Got it? All right. Now we can look at these two. Give me a nice geometry word about the relationship between these two angles right here. Give me a good, nice, solid one word. What are they? They're not congruent necessarily. Are they supplementary?
Complementary.
Complementary. Complementary is what? They add up to what? 90. What's the supplementary? 180. Okay. All right. I know that was exciting, but everybody calm down. Okay? They're complementary. So complementary means they do what? They add up to 90 degrees, 90, okay? Now look, technically all three of these add up to 180, right? But do you really need to even consider this? No, just take it away from the 180 already. So the complementary angles of a right triangle always add up to 90 degrees. So that's what we do. Now look, I know what you were doing this stuff from really the beginning of the year. Do you remember doing that kind of thing? You find a relationship. What do? You either like set them equal to each other, you add them up, set them equal to 90, add them up, set them equal to 180, and all that kind of stuff. I know what some of you guys do. Some of you don't know what to do, so you're like, just set them equal to each other and see what happens. Who's ever actually gotten lucky? They didn't know what they were doing, but they set them equal to each other and you got the right answer. Okay, I'm seeing about half the class right here, all right? And that's okay, I guess. I mean, you know, if you're in doubt and you don't know what to do, you might as well set them equal to each other. But if you did that here, would you get the right answer? No, you wouldn't, because they're not necessarily equal to each other. What are they? They are complementary to each other. So that means I add them up. So 4x plus 2 plus 9x minus 3, that equals what? 90 degrees. Good. My last class I put 180, and somebody said, Mr. Hamrick is not 180, so I had to cross it out. So I'm telling you my mistake twice. All right. So let's do this real quick. What do we got? 4x and 9x, 13x. What? Minus 1 equals 90. Add a 1. Just give me a second. 92. Does that come out even?
You skipped a step.
What did I do?
Well, you said minus 1 and then you said 91.
Oh, right. So that should be 92, right? I did that, and I just, yeah. What am I doing? This should be a 90, right? Add a 1. Thank you. See, I make mistakes all the time. That's okay. So 91 over 13, I believe, is 7. Is that right? So x is 7. Is that our answer, though? No. Just wait. I know. You can wait. All right. So x is equal to 7. So what do we have here? 4 times what? 7 plus 2, and that's 28 plus 2, which is 30 degrees. So what kind of triangle do we have? 30, 60, 90. Now, if we knew some sides, we could find the other two pretty easy, couldn't we? All right? Because the short side's half, the hypotenuse, blah, 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 and all that kind of stuff. Who knows? They may have a question in there where you have to do that kind of stuff. All right? That's it. You are doing numbers. Let's see. I've got my book up here somewhere. Here it is. You're doing 11 to 30. I'll give you the page number. Of course, it's section 10-4. You're doing 7, 13, 7, 14. And you're doing 11 to 30. Does that mean anything to you when I say 10-4? Back in the 80s and probably 70s and 80s.
It's all good, right?
Yeah, it means like, how do you know 10-4 from what? Like walkie-talkie, CB radios. Anybody have a CB radio? You even know what it is? Back when I was your age, like everybody had a CB, and you would talk. You'd say, "Hey, good buddy," and all that kind of stuff. Anybody know that? And people would say 10-4. People would say 10-4, good buddy. Anyway, all right. Say bye, everybody.
Bye.